Welcome back to FaceItNet. Today, in this video, I'm going to show you and I'm going to talk to you the difference between HTTP and HTTPS. As you all know, HTTP is not a secure application layer protocol to do any web browsing. So to overcome from this vulnerability, HTTPS protocol is introduced. So in HTTP, the communication between the server and the client is encrypted. That means you're not going to see a plain text communication. All the text or all the messages that's transferred from client to server is all encrypted and it's an unreadable format. Only those who have the keys to decrypt can only read and understand. So, how does this really works? We always say HTTPS is secure. What's the difference really we see from HTTP to HTTPS? So before we go to HTTPS, let's quickly have a look at what is HTTP. It is the simplest communication. Means what? There's a three-way handshake. When they do the three-way handshake, it becomes a plain communication. That means the client computer sends a synchronization message to the server saying, hello, I want to communicate with you. The server machine replies back to you, yeah, I can communicate with you and also I want to talk to you. So that's why acknowledgement, which is a synchronization response, and then the server sends a synchronization message to a client computer. Then the client computer accepts that by sending an acknowledgement. So that's a three-way process. That's why it's called three-way handshake. Once this three-way handshake is completed, then what happens? The data communication starts. When the data communication starts, they just transfer the messages as a plain text communication. So which is not possible today. Today, we can see the number of attacks has increased massively. Over the past years, the attack vector has gone really higher. So the plain text communication is not going to be possible. We need to have a encrypted secure communication. That's why HTTPS is there. HTTPS is very complex. As you can see here, HTTP was just a very simple three-way communication, but we can see here there are so many other conversations happening. Let's go and have a look at what's really happening behind this HTTPS. So, the first thing, the client computer sends a hello message, which is called client hello message. Right, so let's consider client computer is a Google server. So client computer, you go to the client machine, text the web browser, type in www.google.com. Right, so that's the client hello message that goes to the server. Now the server receives this message and then server will reply back to you with the hello message. Here in this hello message, what happens is server is not going to just send a simple hello message, it's going to send the hello message with something called a public certificate, right? So what is public certificate? It is called a certificate that is being given to any machines. You can request this certificate from a certificate authority. So let's have a look at how we really get this public certificate first thing. So what happens? The Google server must have received a certificate, we call it as a service certificate, from a certificate authority. The certificate authority use X509 protocol. Using the X509 protocol, it sends a certificate to your computer. So when they create the certificate, we call it as a CA certificate, Certificate Authority Provided Certificate. There is another certificate called self-signed certificate. So I'm not going to talk about the self-signed certificate. I'm going to only talk about the CA certificate. So what is in the CA certificate? It has primarily two important keys. One is called public key, the other one is called private key. So these two keys will act for this secure communication. So these two keys will be transferred to the requested machine. So which is in my case, Google server. So Google server has got a certificate now. That certificate has a public key and has a private key. The private key is private, so that's when you cannot share that with anyone. It's only available with Google server, nowhere else that you have this private key. But the public key is available everywhere. Anyone wants to communicate with Google server will have this public key. That means the Google server will provide the public key for the conversation purpose. So now, since this Google server had this public key and private key, he's going to keep his private key with himself, but he's going to share the public key with the client computer here. So now the client computer receives a server hello message with a public certificate, which is the public key. So in the public certificate, you will have the public key. So he receives that from the Google server. Once he receives, client computer should verify that he is receiving this certificate from Google, but he needs to verify whether this is a valid certificate, because anyone can send the certificate to you and saying that this is my public key certificate, and you make sure that this is the key that we are going to use it. But there is no guarantee that it can be the valid certificate. So what you need to do, you need to go back and check whether this received key or received certificate is a valid one. So what happens, the client computer now going to communicate with the certificate authority using a protocol. In the past, this was a database where you have to go and check in the database to verify whether this is really provided to Google. But since the database size is massive, we have around 800 million websites, and then you can't have that many information in a database, and you cannot search it in a quick timeline. So it's not going to be practical. So they introduced something called a new protocol called Online Certificate Status Protocol. So what happens is, now the client computer is going to verify the certificate with the certificate authority using the Online Certificate Status Protocol. That means he's going to the CA and ask, hey, I received the certificate from Google, and he has provided me this as his public key certificate. Can you confirm me whether this is the public certificate that you have given to Google server? Now the certificate server or certificate authority going to reply and say, yep, that's the certificate that I have given to Google. You can trust it. So now you certified or you verified the key or the certificate that you received from Google server hello message. Now what happens, we are going to use this key to create a new sessions. So when we say HTTP is secure, of course they use the certificates, but if you always use the same certificate, then the chances of compromising and somebody understand your certificates and get the certificates and communicate as yourself with the Google is possibly, it's a possible opportunity. So now to improve the security, what HTTPS does, it's used for every single session they use a session key. Once the session is terminated, that key is discarded and then you cannot use that key anymore. So this is a session key only for that specific session. Now what happened? The client computer has got the public key or public certificate, Google's public certificate. So it's been verified. Now he's going to create his session key, right? So you can see it's creating a pair of keys, right? Two keys is going to create or generate from the client computer. Technically, it is a temporary key. So he creates the temporary key. Now what happens? This temporary key must be shared between the client and the server so that you can use that for the session communication purpose. For me to transfer these two keys to the Google server is where I'm going to use this public certificate. So now the client computer again has verified the key and he has created a new pair of keys. What he is going to do, he is going to put the new generated key inside the public certificate that he received with the public key he received, and he's going to put it there as an encapsulated one. So now your session key, the one that you just generated, is encapsulated, or it's gone inside your new or your received Googled public certificate. So this is now like a closed one. So you put the session key and you locked it using the received public key. So this cannot be opened. Remember, this key has only a lock, one single lock. That lock is only with Google here. So what happens now is going to transfer this new key, which is a session key, is going to transfer it to Google server, right? Keep in mind, he's not, when he transfer this Google key, he's going to transfer it using the public key, right? So public key is being used to encapsulate the generated key, and I transfer it to Google. Now Google received this one. Remember, he has got the private key. So using the private key, he decrypts that one. So when he decrypts, he receives the generated key pair. So now we can see both client and the server has got the newly generated keys, right, pair of keys. So one key is for the encryption, the other one for decryption. So they're going to use one to encrypt the communication and the one for decrypt purpose, right? But they have got both keys now. So both of the communication parties has got the key. Now what happens, using this key, they need to now negotiate and confirm all good. We are going to use it. That is the negotiation step, next one, right? So using the negotiation, which means they're going to confirm the key strength, whether they're going to use TLS or SSL version, whether it is key length, how big the keys should be for the encryption and decryption purpose. So they negotiate this one, right? Once the negotiation is completed, now the session, which is a secure session, is established. When the secure session established, we get the data, right? So client machine has the data, use the lock, and that's lock means it's to encrypt. So now it's encrypted. So the encrypted data is being transferred to the destination. Destination has the pair key, and he used that key and he decrypts it. Now the data that has created from the client computer is gone to the server, and no one can decrypt this data. The reason, to decrypt this public key, you need the private key. That private key is only with Google server. And again, even if they decrypt inside, they have the session communications. So these two levels of sessions will always make sure the HTTP communication is secure. Keep in mind, once the session is terminated, these session keys are discarded. We will regenerate. If the client machine wants to communicate with the Google server one more time, then they will have to regenerate a new session key, which is a pair of keys, and they will then encrypt that one using the public key, and then again they will go for a SSL session negotiation, and once the session is negotiated, then the communication will start as an encrypted communication. So you can see for every single session that we generate a new session key. So that's why HTTPS is more secure than HTTP. Hope it makes sense to you all. Send me messages if you got any question. Post a message to me. Thanks.